This will be our last section that we look at in chapter 1. And this is on basically creating new functions. Like you're given two functions, and you combine the two that you have together to create something new. So we're going to talk about different operations we can use on functions, including composition, okay, which is an operation we can use. So the most basic way we can take two functions and combine them together to create something new is to add them, subtract them, multiply them, or divide them. Okay, here's a really kind of simple example. Say f of x was 3x, and g of x was, 7x. And I said to you, I want you to create a new function. Let's call that function h of x. And it's going to be created by taking f of x and adding g of x to it. That's going to be my new function. So then h of x would really be 3x plus 7x, which equals 10x. So there's my new function. H of x equals 10x. That's a new function created by taking the two existing ones and adding them together. Now, the only reason I could actually add these together and get something as a single term is because they were like terms. If f of x was like 3x squared, and I wanted to add them together, you can't combine 3x squared and 7x now. You would just have to write the answer as 3x squared plus 7x. Right. So I gave you one to combine where you did have like terms. All right, let's try this one. F of x plus g of x. These are not like terms. X squared and the square root of x plus 1. So if you want to create a new function by combining these together with addition, all you can do is just add them together and write that down. That's it. So x squared plus the square root of x plus 1 is a new function. It would look different than either of the originals if you graphed it, but it's created by taking the two you started with and adding them together. Here's an example with division. We took our first function we were given, we took the second function we were given, and we combined them by dividing them. Now there is a problem in this case. When we divided them, what ended up happening that we don't like? Yep.
Square root on the bottom.
Yeah, we've got a square root on the bottom. We generally don't like to leave a square root on the bottom. So technically we should fix that by multiplying top and bottom by the square root of what's in the bottom. It's not going to get rid of the square root, it's just going to move it to the top. So the proper answer for this one, as much as we can rationalize and simplify it, is x squared times the square root of x plus 1. And then in the bottom, the square root of x plus 1 times the square root of x plus 1, the square root cancels. And you're left with x plus 1. So that one had a little bit more work just because of the square root. Any questions on that one? Okay. So when we take two functions and combine them together, what they're going to ask us to figure out is the domain and the range. So maybe f of x, it had its own domain before we started. G of x had its own domain, but now we've combined them together to create something new. Well, that new thing has a domain, and we're going to have to find it. And the simplest way to visualize it would be like this. Let's say that circle represents all the numbers in the domain of f of x. Let's say this circle represents all the numbers in the domain of g of x. When you combine f of x and g of x together to create something new, the domain is the overlap. It's all the numbers that were in the domain of f of x and g of x. So the domain of the new function is all x values that belong to the domain of both original functions. And most of the time that works fine. The only time we can run into a slight problem with that is if we combine two functions together with division. Because remember, you're not allowed to divide by what number? Yeah, Jake?
0.
You can't divide by 0. So if you combine functions together in a way that causes all of a sudden for you to have a fraction that could result in you dividing by 0, you also have to say that that value is not in the domain. So we want to check for where they overlap. We want to check where the values that are in both f of x and g of x, and make sure that none of those values cause you to divide by 0. So now we'll try an example there. Okay, let's start with this one. We don't know the operation yet. All I'm doing is giving you the two original functions, f of x and g of x. F of x is the square root of x plus 3. G of x is the square root of x minus 2. All right, so now Jake said, I asked the question, what can we not divide by? He said 0. That's good. So dividing by 0 is something you have to watch out for. What do you have to watch out for with square roots? You can't take the square root of what kind of number? Yeah?
Negative.
Negative. Is 0 okay? Yes, you can take the square root of 0. But you can't take the square root of a negative. So we got to make sure whatever you plug in for x doesn't cause this to come out negative. So in other words, think of it this way. For the top one, you want x plus 3 to always be greater than or equal to 0. You never want x plus 3 to be negative. And to get x by itself, Isaac, how would I get x by itself here?
Minus 3.
Minus 3. So in other words, we want x to always be a number that's greater than or equal to negative 3. That's the domain of f of x. You can write it as an inequality, just like that, or you can write it this way. Does anyone remember from last week, what does it mean when you put a bracket on a number? Yep. Yeah, it means equal to. It means to include it. So I'm saying you can include any number from negative 3, including negative 3, up to infinity, as high as you want to go. That's your domain. How about the bottom one? Anybody tell me what my domain would be for g of x? Chris?
It would be the bracket and 2 to infinity.
Correct. In that one, you have to pick numbers that are 2 or higher. If you pick something lower than 2, like let's say you pick 1, 1 minus 2, That's a negative number. You can't take the square root of a negative number. Okay? So we can pick any number from 2 up to infinity. Now, when we combine these together, the domain is the overlap. So think of it like this. 0, 4, negative 4. Negative 3 to infinity would look like this. Negative 3 to infinity. 2 to infinity would look like this. So by looking at that, we should be able to see the overlap. Okay? In other words, numbers that are in the domain of f of x and g of x. So let's write down what we would get if we combine these functions by adding. These are not like terms. For square roots to be like terms, you'd have to have the same thing here and there. So they're not like terms. So there's not a lot we can do to add them together, other than just write it down. So square root of x plus 3 plus the square root of x minus 2. Okay, so there is our new function by adding together the old ones. And now, what do you think the domain would be? We have to pick numbers that work in both. All right, does anybody see what the overlap is between f of x and g of x? What numbers satisfy both? Yep. Yeah.
X is greater than or equal to 2.
Yeah, it has to say greater than or equal to 2. That is correct. Those are the numbers that would work in f of x and g of x. It's like the overlap in that Venn diagram. So greater than or equal to 2. And do you have to worry about dividing by 0 in what I just clicked? No, there's no fraction there. So you don't even have to consider dividing by 0 in that case. All right, let's try f of x divided by g of x. All right, so we've got f of x. We've got g of x. There's our function. Not quite the way we'd like to leave it, but what do I do to fix that so the square root's not in the bottom? Yeah, Sarah?
You multiply by square root of 92 over square root of 92.
Square root of, can you say it again?
Square root of x minus 2.
X minus 2. Square root of x minus 2. And in the top, it's just going to be square root of x plus 3, square root of x times square root of x minus 2. And in the bottom, the square root cancels out. So there's your formula. Now, we want to look for numbers that are in the overlap and do not include any numbers that would cause you to divide by 0. So we already know the numbers in the overlap. We did that on the last one. But make sure that none of those numbers would cause division by 0. So anyone think they could give me the domain of this one? Yeah, Jake?
X has to be greater than 2.
Greater than 2, not greater than or equal. From 2 to infinity. Okay? So the overlap is greater than or equal to 2. But the problem is, if you equal 2, you're going to cause divide by 0. That's a separate problem. So we don't want to divide by 0, so don't use 2. Greater than 2. And that's the domain for B. Okay. Any question on that one? All right. That's fine. Let me see, we're gonna do, all right, let's try this one. Let's find the domain and the range of this one. Okay, so we'll practice domain and range a little bit. So f of x is the absolute value of x, and g of x is x. Let's fill it in. F of x divided by g of x. Look at f of x. It says absolute value of x. Are there any numbers in math you are not allowed to take the absolute value of? But Ethan, what do you think?
Irrational numbers?
So you wouldn't be able to do something like this?
Okay, then nothing.
So that's okay then, right? Yeah, so what numbers can you take the absolute value of?
Everything.
Everything. The domain of f of x is all real numbers. You can take the absolute value of anything you want. How about g of x? That's just plugging a number in for x. What numbers would you be allowed to plug in for a variable? Yes?
Anything?
Yeah, anything. So f of x and g of x both have domains of all real numbers. You'd never be taking the square root of a negative in either one of these, and you'd never be dividing by 0. So no problems at all. Now let's look at this one. Is there anything I'd have to be careful about here? Chris?
The denominator cannot be 0.
Right, and we don't want to plug in 0 for x. Not that it's a problem in the top. You can take the absolute value of 0, but then you'd be dividing by 0. Okay, we don't want to do that. So on a number line, think of it this way. You can pick any number from 0, as low as you want to go, not including 0. There's a hole right there. So you cannot include 0. So the domain is from negative infinity up to not including 0. That's this arrow. But you can also pick numbers higher than 0. You could pick anything from 0, not including it, and up. So there's just one number you're not allowed to use, 0. Anything lower, anything higher is fine. This represents anything lower. This represents anything higher, from 0 up to infinity, not including 0. And when you have two different intervals you can pick from, anything less than 0 and anything greater than 0, we put this symbol between them. That U symbol means union, or a simple way to say it is or. You can pick any number less than 0 or any number greater than 0. Just don't pick 0. That's my domain. My range. Well, let's think about the range a little bit. Let's pick a number and plug it in and see what happens. If you plug in 5, what do you get in the top? Oh, Tyler?
Maybe absolute value of y.
Yeah, which is 5. And what do you get if you plug 5 into the bottom? Chris? Oh, yeah, you too. Go ahead, Tyler. 5. And what's 5 divided by 5? 1. Right, let's try plugging in 10. Casey, if I plug 10 into the top, what do I get? 10. And Isaac, if I plug 10 into the bottom? 10. And I get 1 again. So if you plug in any positive number, okay, any number on this section, you get a value of 1. Let's try plugging in a number in this section. Okay, let's try like negative 8. Abigail, if I plug negative 8 into the top, what do I get? 8. And what if I plug negative 8 into the bottom?
8.
If we plug in negative 8 right here, negative 8. And that's negative 1. So if you plug in a number from the negative section, the answer always comes out to negative 1. So this range is very specific. It only gives you 2 numbers. I don't care what you plug in for x. No matter what you plug in, the answer is always going to be 1 or negative 1. Those are the only 2 answers you'll ever get. So for the range, that's what we can write. And you write it like this. Negative 1, comma, 1. And what that means when you put it between those curly brackets is it means what's inside here is a list of numbers. And we are listing every single number in the range. All 2 of them. Negative 1 and positive 1. How come we don't do that with something like this? Why can't I list every single number from 0 to infinity? And Jack, if you have your agenda, I'll just sign up for a piece of paper. Why can't we list every number from 0 to infinity? Yeah?
And that's like a large amount of numbers, and it's pretty unrealistic if you're going to write out every single one.
Yeah, you can't, when you have to write out a range, you can't even list every number from 0 to 1. You can't even list every number from 0 to a half. There's too many. So, usually, we can't list every single number, right? We have to specify it as an interval. From here to here, including everything in between. This is a very special case that we could do. So, any questions on that idea? Combining functions by dividing. We did one with adding. You could do subtracting. All right. So the last operation we're going to look at is composition. So composition is a way to create a new function and it combines 2 functions together by plugging one function into the other. That's the simplest way to kind of say it. So let me show you. So first of all, we need 2 functions. Okay, I have one here called g of x, and I have another one that's called f of x. We're going to try and find this. In that red box is g of f of x. That's how you pronounce it. So if it said to do this, g of 4, what that means to do is take what's inside the parentheses, fill it into that formula, and tell me the answer. So in this case, plug 4 into g and tell me what you get. So you plug in 4 for x right there, and the answer would be 2. Okay. So this notation means take what's in the parentheses and plug it into the letter that's to the left. Well, this means exactly the same thing. Take what's in the parentheses and fill that into function g. That's called composition. So let's write down what f of x is. G of, that's not going to be a number, it's going to be a formula. G of x squared plus 3. That's what g of f of x means. So look at function g, and everywhere that you have a variable in function g, replace that variable. And can you just shut the door for me? Replace that variable with x squared plus 3. So what we're going to end up with is the square root of x squared plus 3. We took one formula and plugged it in for the variable in the other formula. That's composition. Any question on how I did g of f of x? Great. Now let's switch it. Let's do it this way. Let's do f of g of x. So leave the letter on the outside alone. We're not going to do anything with that right now. We're going to look up what g of x is. Right, so Matt, what is g of x equal to?
That's equal to square root of x.
Yes, it's the square root of x. So now, in formula f, replace all the variables with what's inside the parentheses. It's like substitution. Change all the variables to square root of x. Let's look up formula f. It's going to be square root of x, and then copy the rest of the formula. Square root of x squared plus, I think it was 3. And what happens there? Something there that we can simplify. Last time there wasn't anything, but this time there is. Yeah, okay, Sarah?
The square root goes away.
Say it again.
The square root goes away because it's square.
Yeah, the square root and the square cancel each other out, and all you end up with is that. Now, we have, even though we're looking at that and say, okay, yeah, x plus 3, there's no restriction on what number you can add 3 to. You can add 3 to any number you want. Yes, but originally you had a square root. And we can't forget that this came from a square root. So when we're taking into account the domain, it's important that we go back and we look at this first. And that's what we're going to talk about. How do you find the domain when you do composition? This is more of a notation thing. I won't use this notation, but if you see a G, a circle, and then an F, it means that. This is the notation that I always use. Just in case you see a problem in the book that says find this, it means that. All right. So finding the domain of a composition function, it's really not the hardest topic in pre-cal. Mr. Babb was just kidding. But there's two steps to it. Okay, two things you have to do. First, whenever you do composition, you have what's called an inner function and an outer function. In this case right here, I consider f to be the inner function and g the outer, because it's on the outside. So you start with the inner function. And then you ask yourself, is there anything in the inner function that I'm not allowed to use? If there is, we have to eliminate those values from the domain. Okay, so we can kind of think of these two steps as like filters. We're going to take all our numbers. We're going to take all real numbers, and we're going to pass them through filter number 1. And whatever is left after that is going to go to filter number 2. So filter out any values that are not in the domain of the inside function. Then whatever values are left from that, pass it on to filter number 2. And now we're going to filter out values that wouldn't work in the composed function. Okay, that's the final answer. So look at the look at your final answer and see if there are any other values you have to filter out based on the composed function. You know you have to filter things out when one of two things happens. Is there a square root in the problem? Or is there a fraction with a variable in the problem? Either one of those things comes up, you have to filter some numbers out. And that's pretty much it. That's the most complicated thing today. Just following those two rules. All right, so I'm going to give you guys two functions. We're going to compose them together and see if we can figure out the domain of the composition. And remember, domain is the values you are allowed to plug in for the x variable. So here's f of x, x plus 1. And g of x is the square root of x. Let's practice just a number first, just to get the idea of composition with a number. Sometimes if composition is not making sense and I show it to someone with a number, then they understand it better. So when you have a number here, the answer that we get when we're done is going to be a number. So can someone explain to me, looking at the inside function, what does g of 9? What does that mean to do? Yep, Sarah?
The square root of 9.
Right. It means, don't worry about f right now. Take 9 and plug it into the g formula. And now simplify. We get 3. Now I have f of 3. What does that mean to do? Chris?
You plug 3 into x in f of x.
Plug 3 in for x in the f of x formula. That would give me 3 plus 1, which is 4. That's composition. Okay, sometimes people think it looks simpler that way because I used a number. It's exactly the same thing I did before when I used a formula. Just plugging in one thing, taking a result from one formula and plugging it into another formula. So now let's try it this way. F of g of x. Okay, keep the f where it is. And Chloe, what is g of x in this case? It's going to be a formula. So it's given to us up at the top.
Square root of x.
Square root of x. Any questions on that first step? Now, take that and fill it in to function f. Okay, Isaac, can you tell me if I fill in square root of x in for f, what do I get?
X plus 1.
So that's the formula for f of x, yes. And what are we filling in for x?
Would be 1.
Square root of x. So what I put that arrow to, that's what you're filling in to formula f. Go ahead, just ignore me. What do you end up with?
X squared.
So take that and put it right there.
Oh, so square root of x plus 1.
Yeah, square root of x plus 1. And that's f of g of x. Okay, let's try it the other way. G of f of x. How about Zach? What's f of x?
X plus 1.
Yep, x plus 1. So g of x plus 1. So take this entire thing and put it into g. So Tyler, if I plug in x plus 1 into g, what do I get?
The square root of x plus 4.
So same thing I had right here?
No,
No, can you explain how is it different?
because the plus 1 is in the square root.
Exactly. Big difference. It's the square root of x plus 1, but the plus 1 is under the root. You said it perfect. Okay. Any questions on that? Okay. So now let's try, we're not going to do it both ways, but I want to practice one with the domain. Let's do, so those are going to be my two formulas. I'm just deciding which way I want to try this. Let's do the second one. Let's find f of g of x. And then we'll do the domain as well. Alright, so this is going to be f of g of x. Alright, Casey, what is g of x?
Square root of x.
Yes. So f of square root of x. So Bailey, in the formula f formula, what am I going to replace all the variables with? So whatever's inside the parentheses, that tells you what you're replacing the variable with. The square root of x. F of square root of x means in formula f, replace the variable with what's in the parentheses. So let's look at that. We're going to replace square root of x. We're going to replace x with square root of x. Square root of x squared minus 1. And Jake, what does that simplify to?
X minus 1.
X minus 1. Okay. So now, when we find the domain, start by looking at this inside function, okay, g of x. Let's go back and see if there were any values we were not allowed to use, okay, or anything we had to be careful about. In g of x, are you limited to picking certain numbers for x? Yeah, what are we limited to?
Positive numbers.
And
0.
0. So we can pick any number 0 or higher. So those are the numbers that made it through the first filter. We're already down to numbers 0 and higher. Out of those numbers, are there any numbers you're not allowed to subtract 1 from?
1.
So if you did like 1 minus 1 on a calculator, we'd say error.
Never.
Yeah, so that's okay. So are there any numbers that you can't subtract 1 from? No. So the final answer here doesn't add any restrictions to our problem. The only domain restriction came from the original inside function. And the restriction there was all numbers greater than or equal to 0. So the domain, 0 to infinity. Yes, I understand you can plug in a negative number into the final answer, but you cannot plug a negative number into this original inside function, and that's important. Okay. Any question on the domain for that one? All right. So let's try one with range. We're going to do another one with domain, but let's try the range too. So the easiest way to get the range is step 1, determine the domain. Step 2, we're going to use the graphing calculator to help find the range. The reason you have to get the domain first is because that's going to tell you how to set your window. We don't want to look at things that we shouldn't be looking at in other parts of the screen. We only want to look at what is appropriate for our domain. So find the domain, and then use the graphing calculator to help you find the range. So I guess this will probably be the only question we really need the graphing calculator on today. All right, let's do this one the other way. I'm not going to do both, but let's see which one we did last time, and let's do the opposite. We did f of g. Let's do g of f. So find g of f and find the domain and the range. All right, g of f of x. Okay, how about now? Let's start by filling in this inside. What's f of x?
Square root of x.
Yeah. So I want g of square root of x. I'm not even thinking about the remaining range yet. I'm just trying to get the formula first. All right. So Abigail, can you explain what this means to me? G of square root of x?
You need to put these negative x into, plug it into their x.
What are you going to plug this into?
Into, like that would be x.
So this is f of x right here, and that's going to get plugged into what formula?
The x in x minus 3.
Yes, we're going to plug this into formula g. So take that, fill it into formula g, which is the x minus 3. Okay, so there's our formula. Now, let's see if we can get the domain. All right, to get the domain, we always start with what? What's the first thing we want to look at for the domain? Jake?
Would you look at the original, like the g of f of x, or would you look at the second one?
We look at something here, but that's the question. Which one do we look at?
The f of x?
Yes, to get the domain, eliminate any values that do not appear in the inside function. All right. So let's start with f of x. Is there any restriction on values you can plug into f of x? And if they see a restriction, or if not, you can say no, you can plug in anything you want. Yeah, Matt?
0 and anything positive.
Yeah, we're already limited to numbers 0 and up. Okay, so we're limited to 0 and up. So that's like our first filter. Filter out everything that's not 0 and up. And now let's look at our final answer. What numbers are you allowed to plug in the final answer? Yeah, Chris?
It's 0 and greater as well.
Yeah, it's 0 and up again. So it's like you filtered out all numbers that weren't 0 and up, and then you're going to filter out all numbers that are not 0 and up. So this didn't add anything new. Right? So the answer here is all numbers 0 and up. So to find the range on my calculator, I do not want to look at negatives on the x-axis. Even if there is a graph there, I don't want to look at it. I have to look at 0 and up. So let's type in our formula, square root of x minus 3. Okay, and on our window, we're only looking at numbers 0 and up. Now, up, well, how high is up, right? I mean, I think 50 is probably more than we're going to need to get a good picture here. But you can set x max as high as you want. Let's set x min at 0. Let's try our y max at 10. I think 800 is going to be way too high. And we're looking for how high and low the graph goes. Okay. So there is our graph. What I should probably do, just to get an idea, let's set the y min a little lower. Just to see if anything's happening. The graph does go below. Okay, and it does. So remember, square root is half of a parabola. It's on its side. Can anybody tell how low the graph goes? What is the lowest it looks like it ever goes? Matt?
-3.
Yep, it does go as low as -3. And then how high is it going to go? Yep,
Forever.
forever. Perfect. It's going to just keep going up forever because a parabola never stops getting wider and wider. Right? And this is half of a parabola. So my range is from -3, that's the low, and it's going to go up forever. Okay, no question on that. All right. Let's see that. Not critical, I talk about. Okay, so this I think is the last thing. And we're not doing that. Okay, so yes, the last thing we're going to talk about is kind of generalizing what we did yesterday. We added numbers in certain spots and caused the graph to like shift up, shift down, left or right. But those transformations that we learned yesterday, they apply to any function. So if I did that, that's a vertical shift of a parabola up 3. Well, if I did this, that's a vertical shift of a square root function up 3. It doesn't matter what function you put here. You can put anything you want. If you put a formula here and then add 3 to it, it'll move it up 3. So that's basically what we're going to write down right now, just generalizing our transformations. And you can shift up, down, left, and right by any real number you want. It doesn't have to be 3. It could be 3.6. It could be 2.417. Right? You can use any number you want to shift up, down, left, and right. That's what this means. But let's start with this one. Does anybody remember when you multiply by a number in front? Okay, like this. What does multiplying by a number in front of a function do? Yeah, Jack?
Vertical shift.
Good. It's a vertical stretch. Could be a shrink. It depends. If it's a fraction, like 1/2, it would be a shrink. If it's a big number, it would be a stretch. How about adding or subtracting a number at the end of a function? How does that move a graph? Add or subtract a number at the end. Yep,
Vertical shift up or down.
up or down, and it would be common sense what you would expect, plus is up, minus is down. Plus, minus. Now the horizontal, I broke it into two separate ones because it's a little more confusing. When you add inside the function, which way does adding inside move the graph? Yep,
Horizontal shift to the left.
yep, to the left. And subtracting inside the function would move it to the right. A negative. When you put a negative in front of the graph, think about we did that yesterday. What does a negative in front of the graph cause it to do? Yep.
Reflect over the X.
Yes, exactly. It's a vertical reflection which flips it over the x. And this one we didn't do as much because with a parabola, you can't really tell. That's a reflection over the y-axis. All right. So that's just kind of summarizing all the transformations we learned yesterday. And that's it. So that's 1.6. All right, so that's the homework for tonight on page 66. And we'll take a look at those questions tomorrow, and then we'll finish up everything for our test on Friday. A reminder, I plan on being at the school tomorrow in case you need help. And if you needed to ever come during like a study or something like that to get help, that's fine too. Just shoot me an email first, make sure that I'm in my classroom.